Hello, we are discussing how to use this method of partial fraction to solve certain integrals. Okay, so let's consider an example. Let's say you will have to integrate 1 minus x over x squared plus x. Okay, so I will show you the algebra. It involves this type of problem involves some algebra to do first, and then the calculus to integrate it. Okay, so let's do it on the side. What you're going to do is this. You're going to start with the fraction that is given to you, the rational function, and then you will first start by factoring the denominator as far as you can. So I can see clearly there's a common factor of x, and then if you pull it out, you will have a x plus 1. Okay. Now, very important, check that the fraction that is given to you originally, check that the degree of the numerator is strictly less than the degree of the denominator. You have to definitely check that, okay? That the degree of the numerator is strictly less than the degree of the denominator. In this case, that is the case, right? The degree of the numerator is 1, x has a highest power of 1, and the denominator is 2, so it's strictly less is good. If that is not the case, if it's equal, the top degree is equal or greater than the bottom, you have to first divide them up, okay? Long division has to be done first and reduce the whole fraction into this situation where the degree of the top will be less than the degree of the bottom. We'll do a problem like that in a separate video. Okay, so for now we are good, and we have these two factors. Now you will be writing down a fraction. Now you are going to split it up into fractions based on the factors in the denominator, all right? Now notice that x is a linear factor, right? A linear function. X plus 1 is another linear factor. So there are ways of writing these fractions. So we will write one fraction for x and another fraction for x plus 1. So they're all linear. They're different than each other. If they're same factor appearing, then there is another way of writing it. And I'll explain that later, okay? So for now, two linear factors that are distinct, you write one fraction for each. Now what goes on the top? That's the challenging part, okay? We don't know right away what goes on the top. That's what you have to figure out. So we put a. A is a constant, remember. Since the fraction, the denominator is a linear, whose degree is 1, on the top you write one less degree, which will be a constant. This one, again, is a linear factor, degree 1, so on the top you will write one less degree polynomial, which is a 0 degree polynomial, which is just a constant. So our goal is to figure out what goes for A and B. Well, if you are very good in algebra and you can probably do it in your head quickly, go ahead, but be careful, right? And not always your factors are going to be that simple. Sometimes you'll have more fractions and then it will get a little bit more difficult to just do it in your head. So you should know the method of how to figure out these constants A and B, okay? So I'm going to show two different methods. This one is the first method, how to find the constants A and B. Okay, first thing first, so once we write down our fractions, this is the very important step, then you start doing the algebra, you actually add them together, the right side. Okay, now when you're adding together, keep in mind, the denominator should be exactly the same denominator as the left. Do not make up your own denominator, okay? Whatever it is, write down the exact same denominator as the left side. Okay, now you have to figure out what goes on the top. Now for two terms, it's easy, it's just cross multiply. So a times x plus 1 plus b times x. All right, so now see, the left hand side is equal to the right hand side. Left hand side we have 1 minus x over x plus 1. Okay, two fractions, they're equal to each other and the denominators are equal to each other. Therefore, the numerator has to be equal to each other. That's the algebraic fact we'll be using. So we can write in the next step, the numerator here is equal to the numerator on that side. And this statement is true for all x. See, we're going to find a and b, right? X is also a variable, but what happens is when two fractions are equal to each other, the denominators are equal, the numerators will be also equal for every single value of x. So how do we find a and b? You just plug in some x value in this equation, whatever you want, but choose wisely, right? Let's see. What kind of x value do I want to plug in this equation so it will make it very easy for me to figure out these two constants? So my first choice will be, I'll plug in x equals 0. Look what happens if you do that. Well, x equals 0 will get rid of this term b completely, right? So plug in x equals 0 to the entire equation and see what happens. So what do I get on the left? I get a 1 is equal to a times 0 plus 1 plus b times 0, right? So the reason I chose 0, so the b goes away completely and I'm only left with a. Oh, a is equal to 1. I got the value. See how easy? Okay, next, can you guess? What is the next x value I'm going to choose? Now I need to find b and I need to get rid of a. How to get rid of a? Plug in x equals -1, exactly. All right, so let's see, plugging in x equals -1, be careful. 1 minus of -1, so that's a 2, is equal to, the a goes away, right? A times 0 plus b times -1. So a goes away, negative b is 2, so b is -2. See, I found out both the variables, the constants a and b. So now that I have it, why am I doing all of this? Because I want to integrate this function, remember? So now I know this fraction that I had to deal with is nothing but a sum of two fractions, a over x, which is 1 over x, and then plus b is -2 over x plus 1. All right, and then you know exactly how to integrate this, right? We have done it in a previous video as well, but this one I actually showed you how to do the algebra to know how to break a given rational function into partial fractions. Thank you.